All right, we're looking at assignment 44, and we're going to do problem 11. So it says point P is located in space 1 Earth radius above Earth's surface. So before I even read anything else, I'm going to draw myself a little diagram, because when I conceptually look at it, it helps me to understand it. So this here is Earth's radius. But now it says it's located in Earth's radius from the surface. Okay? So now this is another Earth's radius here. Okay? So the trick to this is from here to here is actually what? 2r. Okay? So that's the trick to this problem. And maybe if you didn't do a little sketch, you wouldn't be able to conceptualize that. So it says that's point P. Determine the strength of the gravity field. So we want to find little g. And then B, determine the weight. So we need to know some stuff about Earth. So Earth, the mass of the Earth is equal to 5.98 times 10 to the 24. So that's not something you have to memorize. And then the radius of Earth is equal to 6.38 times 10 to the 6 meters. Now remember, you have to use your standard units, kilograms and meters. So for part A, our equation is little g is equal to big G, the universal Newtonian gravitational constant. This would be the mass of the Earth over the radius square. So this is 6.67 times 10 to the negative 11 Newton meter squared per kilogram squared. And that's not something that you have to memorize, but after you write it so many times, you kind of can't forget it. The mass of the Earth, 5.98 times 10 to the 24 kilograms, divided by, now remember it's 2, so what I'm going to do is I'm going to write 2 times 6.38 times 10 to the 6, and then I'm going to square the entire thing. So when we do all that on our calculator, it comes out to be 2.45 meters per second squared. And that's a certain distance above Earth. Now if I got like 20, I would know I made a mistake, because if on the surface I know it's 9.8, it's going to be less further from it. Does that make sense? So again, you always want to ballpark your answers and kind of say, well, what makes sense physically? Because they're not going to have answers that don't make sense physically. All right, part B, it says if they determine the weight of a 320 kilogram mass. So weight is mass times gravity. So it's just 320 kilograms times 2.45 meters per second squared. So when I do all this on my calculator, it comes out to be 784 newtons. And that's it. And, you know, all of these are relatively, you know, the same thing, straightforward. Okay, no little tricks. But again, when you have something like this, make sure you read it, because a lot of times people get confused and they'll just use this distance. So let's say it wasn't Earth's radius. Let's say just that they gave you this. You have to remember to add the radius of the Earth from the center to the surface, and then how high it is above Earth's surface to it. So that's one of the most common mistakes.